This is Kilo 1, November, Bravo, Tango. My name is Neil. Today I'd like to share a step-by-step demonstration of building an in-fed, half-wave, 80-meter antenna and the UNUN to go with it. I have to say right up front that this design is not mine, as I've copied a QRP version of the no-tune in-fed half-wave antenna that I bought in a kit form from the QRP guys. I use it for a homebrew 80 through 10 meter transceiver. It worked so well that I built a more robust version that handles more power. I use a manual T-type antenna tuner with this antenna. The only time you might not need an antenna tuner is if you're only using a narrow range of frequencies where the antenna length is resonant. I like the in-fed because it can be deployed in so many different ways, from your house window to a tree as a sloper, or over a tree as an inverted V, or as a vertical L, or an inverted L, or well, wherever you choose to deploy the in-fed antenna, there is a way. I carry one in my car that uses the metal car body as its counterpoise. It's quick, and it's quick to deploy and quick to take down. You can pull off the road and throw a rope over a tree and be on the air. Then in 5 minutes, you can have it wrapped up and on the road again. To me, it is a logical MCOM field deployable antenna. For the 80-meter version, the length of wire is about 130 feet, depending on the type of ground that you're over or the deployed position of the antenna. The length may be a little different. I use insulated wire in case leaves, brush, or limbs happen to touch the wire. So like I said, the length is about 130 feet, but keep in mind that the actual resulting frequency of resonance and feed point impedance will depend on the height of the wire above ground, the slope of the wire, the conductivity of the ground below, the dielectric constant of the ground below, and the presence of trees, buildings, metal structures, or towers nearby. So be sure to check the impedance and SWR of your antenna before transmitting. Here is a picture of the mounting box of my in-fed on the back side of my garage. You can see the UNUN is in a weatherproof box with the connections on the bottom. It's fed with a 50 ohm coax that runs inside the metal skin garage. The antenna wire connects to a bolt on the bottom left with a washer and wing nut. Notice the eye bolt on the right side that provides a place for a strain relief spring to absorb the movement of the trees. I use a screen door spring. Using an arborist bag, the wire was taken across the upper branches of a nearby tree at about 16 feet, and then over the top of another larger tree further out back. The antenna is terminated in an insulator and a rope goes down to a fence post to secure the antenna. I'm sure the insulation will eventually wear through from the rubbing of the trees, but for now it's doing its job. Maybe your site will present a better deployment. Now the wire part is pretty straightforward. I use THHN, thin, 12 gauge stranded wire. I buy it in 500-foot spools because it's cheaper that way. 500 feet cost about $60 at this point. 14 gauge will work also, but 12 gauge is stronger. I crimp and solder an eye fitting on one end so it will mount onto the bolt. The strain relief spring keeps the pressure off of this fitting. Be sure to allow a drip loop so the rain will not run down the wire to the connection. The other end will be tied to an insulator. I recommend cutting the wire a little bit long to start with and then adjusting it to resonance. So let's look at the UNUN. Since it will be outside, use a weatherproof box. This 4 by 4 inch box cost me $8. So gather up your hardware and mark the position of the holes for the hardware and then drill. I use a SO239 panel mount coax fitting. It cost me about $3. The SO239 fitting is held in place with 3/4 inch long number 6 32 machine screws and nuts. I use 3/16 by 1 inch bolts and wing nuts for the wire connections. The eye bolts are 3/16 inch also. So drill the holes and mount the SO239 and the eye bolts. Now we're ready to focus on the toroid. In this project I'm using a T200-2. So what does that T number mean? T stands for toroid, 200 means it's a 2 inch in diameter, and the -2 defines the metal properties. The -2 is okay for the 40 through 80 meter HF frequencies. If you're planning to tune into the higher bands, like 6 through 17, then a -42 or -43 would be better. Now there's many types of toroids and hundreds of differing opinions of which is best. As far as wire, you can use magnet wire with enamel insulation, or you can use silicone insulated wire, which is high temperature resistant, or as I am, you can use vinyl insulated wire. I'm not planning to overdrive this antenna. The UNUN is a direct copy of the one I'm using, and it handles up to 100 watts without any problems. If you're running max power, then use silicone insulated wire and a beefier toroid. In the past I've had misfortune with magnet wire arcing because the insulation cracked when the wire was bent around the toroid. As you can see, I chose to use a red and a white wire so it would be easy to differentiate. So start by twisting the ends of the red and white wire together for about 3 inches. Those twisted wires will make up the first bifilar wraps around the toroid. Notice the direction of the wraps. I prefer to use solid wire instead of stranded as it stays in place better. Once the 3 turns of twisted wire are complete, continue on with the white wire as shown in the pictures. Every time the wire passes through the center of the toroid, it counts as a wrap. Make 9 wraps with the white wire. Then on the 10th wrap, take the wire through the center to the opposite side of the toroid. Then begin wrapping in the opposite direction. Make 9 wraps. Make sure the wires are evenly spaced and then secure the wires in place. I like to use hot glue, but have used zip ties in the past. Both work. Some people use electrical tape. I don't like that, but that's up to you. Once the glue is cooled off, set the toroid in the box. Now determine the length and layout for the wires. The white wire goes to the antenna bolt. The red wire gets soldered to the center connection of the SO239. The twisted pair goes to ground on one of the bolts holding the SO239 in place. A small jumper wire connects the SO239 ground bolt to the counterpoise or ground bolt and wing nut. Strip the ends of the wires, crimp and solder the connections to make the hookups. Once that is done, I use a clear non-conducting construction adhesive to secure the toroid in place. So now check your connections, and if all is well, put the lid on, and hopefully you never have to take it off. Now let's talk about end-fed antennas. You may have read in advertisement that somebody's super duper in-fed antenna doesn't need a counterpoise. But don't believe it. An in-fed without a counterpoise is using the outer surface of the coax braid as a counterpoise. If the coax feed line is like mine, running along the underside of a metal roof, well, there'll be a very poor performance. That is why there's a bolt and a wing nut for a ground or counterpoise. In my installation on my garage, I cut a piece of wire and laid it in the bottom of the garage gutter. Even when the gutter was full of solid ice, the antenna worked just fine. I also ran a wire to a ground stake. The simplest solution is to run a wire to a ground stake. Another solution is to run a wire on the ground or a few inches underground along the same direction of the antenna. Why does it need a counterpoise? Because every antenna that works is electrically a dipole. Alternating current and radio frequencies need a place to oscillate. So that is a quick and dirty basic building of an in-fed half-wave 80-meter antenna. Let me know if you have any questions or comments. Thank you. This is Kilo 1, November, Bravo Tango.